right, as promised, on to the possibility of an excess reagent. Sorry, my camera is a little crooked. So this problem, notice, gives us two masses to start with. 15 grams ammonium iodide reacts with 15 grams lead 4 nitrate. Sorry, I changed my mind there. And they asked us how much solid is produced. What mass, in fact, of solid is produced. So I have two solids here, or two masses here. I don't know which one to start with. But our process is going to begin the same. So just like before, step one is that balanced chemical equation in any and all forms. So ammonium iodide +1 -1 check, reacting with lead 4, what is it, nitrate? +4 -1, whoop, is going to yield lead 4 iodide and ammonium nitrate. So quick balance. Let me see if I can do this in my head. So I'm going to need 4 of these and 4 of these, and that should do it. Solubility rules. Rule 1, ammonium is soluble. Rule 2, nitrates are soluble. Rule 3, this is an exception to Rule 3. Rule 2, nitrates are soluble. So this thing here is the solid product about which they speak. Step number 2 was to map out your conversions. Now we're going to have to do this for both of my reactants because I don't know which one runs out first. So we'll do this one at a time. So map out conversions for one reactant. So the beginning, always a good place to start. So let's start with that 15 grams of ammonium iodide. So I'm starting off in grams of ammonium iodide, and ultimately they ask for mass of solid product. You have two choices here. We can take both of these conversions from grams of reactant all the way to grams of product, and then choose the smaller one, or we can stop at moles of product and then convert to grams for only the smaller one. For this example, I'm going to show you stopping at the moles. So we're going to stop at moles of our product. This way, I only have to convert to grams once instead of having to deal with that twice. So, similar to last time, grams doesn't help me much. All of these relationships are done in moles. So the first thing that I have to do is to convert to moles of that reactant. From there, hop over to moles of our product, and we're going to end it there. Notice this only requires 2 arrows, where going all the way to grams of product requires 3 conversion factors. So we're going to stop here. Grams to moles requires the formula mass. So the formula mass of ammonium iodide, let's see, we have 1 ammonium, we have 4 hydrogens, and we have 1 iodide. 126.9. So 144.95 grams of ammonium iodide per 1 mole of ammonium iodide. That takes care of my first arrow. My second arrow is that mole ratio that I get from my balanced chemical equation. So 4 moles ammonium iodide to 1 mole of my lead iodide. So let's go ahead and set up our boxes, set up our conversions for this first reactant. Started off with 15 grams of ammonium iodide. Convert out of grams to moles, so 144.95 grams ammonium iodide. Don't forget that number, unit, and thing. 1 mole on top. So we took care of those 2 pieces. 4 moles of ammonium iodide to 1 mole. There. So let's see, 15 divided by 144.95 times 4 gives me 0.025. We'll carry this out a ways. Moles of my lead iodide. Now that's how much I would produce if I had 15 grams of ammonium iodide and way too much of my lead nitrate. But that's not the case. I also had a limit on my lead nitrate. So that means I have to map out my conversions for my second reactant. We got to do it again. So, here we go. It starts me off, if you remember, all the way up at the top of our problem in grams of lead nitrate. And we want to go all the way to moles of lead iodide. So similar scenario here. Lead nitrate, grams, don't help me too much. Gosh darn it. Grams don't help me too much. Got to convert to moles to be able to use that mole ratio out of my chemical equation. So, grams to moles of my reactant. And then 2 moles of my product. 2 arrows, 2 conversion factors needed. So, first things first, formula mass to get me from grams to moles. So, let's see, lead is 207.2 plus, now how many nitrogens do I have? There's 1 nitrogen per nitrate, but I have 4 nitrates. So, that's 4 nitrogens plus my oxygens are coming in sets of 3. I have 4 sets of 3, so that's 12 oxygens is a big old molecule, my goodness. 455.24 grams of lead nitrate gives me 1 mole. And then moles of reactant to moles of product comes from our mole ratio, balanced chemical equation, way back up there. 1 to 1. We like this. Makes life easy. So 1 mole lead nitrate equals 1 mole of my lead iodide. All right, both arrows taken care of. So now we can convert our second reactant. Start off with the number they gave me was 15 grams lead nitrate. Grams to cancel. There's the next place grams appear. Number, unit, and thing. Takes care of that piece. Other half has to go on top. Don't forget that any one of these top and bottom sets has to match a conversion factor. It must still be equal, must still be true. So let's see, grams cancel, lead nitrate cancels. 1 mole lead nitrate to 1 mole lead iodide. So that's 15 divided by that 455 number. 0.03295. And this is moles of lead iodide. So now I have 2 values. If I had 1 limiting and 1 excess, this number coming from if I had a limited amount of ammonium iodide and way too much of the lead nitrate, I would get this amount. If I had a limited amount of lead nitrate, I would get this amount. This is the smaller of the 2. So step 6 is to choose the smallest. And the reactant that gave you that smaller value, that is your limiting reagent. So ammonium iodide is in fact my limiting reagent. And finally, we're going to convert this guy to mass. So we said my limiting reagent is in fact my ammonium iodide. Remember, it is the reactant that gave you that smaller number. This here is not the limiting reagent. Your limiting reagent is a reactant. Woo, gotta hurry, running out of time. Grams to moles is formula mass. So formula mass of lead iodide. Woo, that's gonna be a big number. 714.8 grams. Woo, my goodness, per mole. Equals, I'm out of space, I'm going to write it down here, so 0.02587 times that monstrosity gives me 18.4, whoop, can only have 3 sig figs, grams of lead iodide. So notice, in this method, I only had to convert to grams once. Here. So I am out of time on this video. I will work a couple other problems dealing with this sort of scenario in up and coming videos. If you have any questions, leave them for me down in the comments box down below this video, and I will get back to you as quickly as I can. Happy stoiching!